as I like to say, now for something completely different. As the industry moves to network-based video and audio, the way you go about doing things is going to completely change. You're not going to have all this dedicated equipment doing dedicated video stuff. There's going to be almost no SDI. Start out with servers are changing. There's a lot of innovation going on in the servers. We're getting servers with 128 cores, 128 PCIe lanes. You want to put 4 GPUs into a server. They only take 16 lanes each. That's 64 lanes. I've got another 100. I've got another 64 to go. Another change is that we will start seeing vendors create cards that are large FPGA array cards. So rather than having dedicated hardware to do something, we've just got this pool of FPGA programmable logic, and you'll take a section of that, and that'll become the switcher, and you'll take another section that will do over, another section will do scaling, and that will become scalable. The other thing that's going on is that network interface cards are becoming more intelligent. It's referred to as protocol offloading. So that when I open a connection to a multicast connection, the CPU does not sit there and wrap and unwrap all the packets. It just simply opens a connection to the NIC. I want to connect to this site, and then the NIC handles all the building of the onion and the peeling of the layers off the onion for that. And then the other big change that's coming is called unified memory. Essentially, everything talks to everything else inside the server. And what that means is that your network interface card can talk directly to your storage or directly to your GPU. So as far as the CPU is concerned, all I do is I open a connection to the NIC. I tell I want this multicast port. Here's the stream. You take care of transmitting the stream. A lot of efficiency there. Software is going to change. It's going to become much more modular. You'll have sort of a backbone software that you'll plug plugins into, modules in. The backbone is what the industry is calling orchestration. It's what sort of keeps everything working together. Actually, so I can see my slide. It will be distributed. It will be managed for that. Configuration automation. If you're dealing with software, your infrastructure with software where you're constantly plugging various things in, you're going to want to make sure that you're creating good configurations. And my background, I came from the DevOps movement. My last job was at Yahoo Sports. How do you manage lots of things? And one of the key things of DevOps was automated deploys, but also automated build and testing of software. You make a change. When you check that change in, then the software automatically goes through and does some high-level checking, just making sure all the various modules still work correctly. Because what happens a lot of times is I change something here and it breaks something over there. On a periodic basis, you'll do deep dive checking. You'll run more exhaustive checks. The other thing is that when you install a new type of module, that module will include a set of test suites around it that get plugged into that infrastructure. This is the way the web environment works. Cluster management. You're not going to have dedicated hardware in your machine room. You're going to have a stack of servers, commercial off-the-shelf servers, a stack of commercial off-the-shelf switches. They're just a lot cheaper than proprietary, broadcast-specific hardware. So in order to handle that, you're going to want to manage it as a cluster. And I'm going to talk about some old software that's called Hadoop, and it's this fairly simple cluster management software. But the general idea is good. Essentially, it's a distributed system, and it was trying to address the problem of how do we process large data files. And at the time, the network was slow, and so it used to be that you would move data to the compute, but all the servers, the data stores had to compute on them. So it put it on its head, said, okay, figure out where the data is, and then ship that compute job there. In a studio situation, a broadcast situation, you're going to have various resources available. It may be video stored on disk. It may be video coming from cameras. It may be video coming from the GPU or the FPGA. And so all your servers will have the ability to do all these things. And so the software will then look and say, which server currently is least loaded? We'll put that task onto that server. NMOS control. NMOS is just a language. It's a control language. And the more things that talk NMOS, the easier things get. In a studio, your control surfaces are quite expensive, but if they're Ethernet connected, it will be pretty straightforward for the vendors to either do a firmware update, so they now talk NMOS, or if that doesn't happen, you can use something like a device based on something like a Raspberry Pi, where it takes the proprietary protocol on one side and translates it to NMOS on the other. The other thing about NMOS is that it's built on open standards. It's not broadcast specific. It's using the same kinds of authentication and control software that is used in the web industry, is used in a lot of different industries. The other change that's going to happen is that data transfer will become frame-oriented. Right now, if you're in an editor and you are looking at the timeline, your software is doing an fopen on a file. It's got this blob of data, and it's just this stream of data that it's got to sit down and figure out how to dice it into frames. 2110, one of the benefits of it, and 2110 may not be the right protocol, there are others as well, but it transmits the data as frame-oriented data. If we keep the data as frame-oriented throughout the process, it means there's a lot less chance of things getting compromised because of conversions. And once we start doing everything as frame-oriented data, there are a lot of innovations you can do. If I'm requesting a stream and I want frames, 1 minute to 1 hour, 2 minutes, 3 seconds, 20 frames, I can specify that frame, and I don't have to nobody has to go there and say, oh, where is that frame in the data stream? We have it as frame-oriented data. IP multicast is going to be big. It's really interesting. The goal of IP multicast is to speed distribution of data while minimizing resources. And in a small network like Studio, when you're dealing with a single subnet, IP multicast is actually fairly simple. The switch does what's called IP protocol snooping. It looks for requests for which ports want this multicast port, makes a list of them. So when it gets a packet for that multicast port, it says, well, ports 1, 3, and 5 want that. It puts on a bus and tells those ports to retransmit it. It's a single operation. It's not the server going over and over again, retransmitting the same thing. It's the switch just saying, chunk, here's the data. It's for that. In the case of IP multicast, larger switches are a win because you're not cascading things through a couple switches. It all can be done on a single switch. Monitoring, troubleshooting. The IT industry has all kinds of monitoring tools, and video has slightly different needs. But rather than trying to reinvent the wheel each time, the industry would do well to look at what the web infrastructure, what the data center infrastructure is doing in terms of monitoring, because they've been doing it a lot longer for IT than broadcast has. There are GUI-based tools, there are standard tools. The other thing about multicast, and this is what is interesting, is that it allows you to plug your troubleshooting tool into a port. If everything's multicast-based, I need to put my vector scope or my waterfall monitor. I just have that connect to the multicast port, because multicast ports can take pretty much infinite clients. The other thing is an object-based file store. This is the other thing that's going to happen. Right now, when you deal with files, quite often you are concerned with what the server is and what the path name to that file is. And if that changes, suddenly you've got to reconfigure everything. In an object store, things are stored very differently. It is referred to as the CRUD model. You create an object, and you store data there. You then read data from that object. You then update the data, and when you're done, you destroy it. Very simple file semantics. Now, the object ID, it will be a UUID. These are those big 32-character numbers that you see that make absolutely no sense, and that's by design. and they're just there. The reason that they're used is because even low-powered devices can create their own unique identifiers without having to go to a central source to say, is this a unique ID? This is one of the real tough database problems to solve in a database. The other thing is that your object ID is location independent. I'm not looking for a server or a half name. I simply query to my local object store to say, do you have this object ID? And if it does, it says, here it is. If it doesn't, you can also then do hierarchies of object stores. It doesn't have the object, but I can query a senior object store to say, well, do you have it? And this actually goes down in an object-oriented environment. Quite often, every node will have their own object store. So that when I'm looking at, say, the timeline and I'm transferring all this video data, at the same time, I'm storing all of those clips in my object store. And that way, the next time I want to scroll through the video, I don't have to query the server again. I have them locally. And that introduces the idea of authoritative, well, it introduces the idea of, introduces the idea of opportunistic caching. And opportunistic caching is why the web industry has embraced it so much. When I go to get an object, I keep it and I cache it. And that way, if I get a request for it again, I have it in my local cache. What's nice about it is that the cache data is not the real data. It introduces the idea of authoritative and non-authoritative data. This is my description from DNS. Authoritative data, the data that is on the object, the parent object store itself, is the authoritative data. It is the actual data. If you transfer the data to a local object store, then at that point, that new data becomes non-authoritative. And this is an important concept because on the local object store, if it's non-authoritative data, you can blow it away at any time because it's not the copy of the data. And when you're doing troubleshooting, a lot of times what you find is you'll get cache corruption. And a simple solution, just the first pass troubleshooting technique, is you just erase the local cache and you let it rebuild itself automatically. And then another area, and this is, I think I have another slide about this, and this is sort of crazy talk on my part. Video data gets stored in a let me back up for a second. Video data gets stored on a file server as a giant blob of data. It's just data. I know how big it is. I might be able to look at the front of it to see what the format is or something like that. But then I have to sequentially go through and calculate, if I'm trying to get to a specific frame, how far into that file do I index before I see the file. On the other hand, if we are transferring all the data as frame-oriented data, so we're preserving the data format that was created initially, we're preserving that through transmission, through processing, then we can actually store the data on the file server. This would be referred to as the backing store of an object store. It would then store the data as individual frames. And I just talked to somebody at Seagate about this, and one of the things is that when you start dealing with big data, most file servers are oriented towards a megabyte or less of data in a file. And when you start saying, well, we have 300 gigabyte files, they sort of say, oh, really? And by organizing it by frames, if you set your block size in your storage to be the frame buffer size, so I store each frame buffer as a separate segment of the data of the disk or the storage. That way, when somebody receives a request for a specific frame, the backing store doesn't have to do any calculations. It is stored, it's indexed, it's stored by frames. It just gives you those frames. And it's a much more logical way to handle it. And I gather that there is a new movement coming out. It's not XML, it's MXL. I don't know what it stands for, but it's one of the things that's really pushing towards is frame-oriented data. The other thing is, as we get accustomed to referencing by simply time code, this is where I want to be. You can do interesting things with JSON. I've got a JSON query for some video. I might be able to add additional parameters to say, well, I want that video, but I'd like it in 1/4 scale or 1/16 scale. That way, the backing store might automatically generate all the smaller, all the scaled down versions, and you're requesting the same frame, but you're saying, I want a smaller size, a different size for it. And all of this is transparent to the end user. And then the last thing is that metadata everywhere. The industry does not understand metadata. Metadata right now is a bunch of individual silos of data. You have camera metadata. You have production metadata. You have script writing metadata. You have costume metadata. You have props metadata. And the problem is that because these are separate aisles, that you can't use them together. Because you run into simple things like one metadata store may say the production company variable is called production company. Another one might say it's prodco. Another might say prodcom. Because they use different labels for that data field, you have to have what I refer to as shimla. You have to have software that translates all the request names into each other. And this is an area that really Synthi should start looking at. They should start looking at how do we create common database field names so that various different parts of our infrastructure can share data. I must admit, my radical thing is that in the cinema industry in particular, all these different parts of the organization, they have guilds or societies, and they're coming up with schemas saying, this is how we're going to store our data. It would be useful if there was some guidance at sort of the top level of how do we start standardizing names. I think that's one more slide. The other thing is that metadata cascades down. One of the interesting things I learned about in school was a script breakdown, essentially where you take a script and you break it down into every individual item you have. And that process is generating unique IDs, object IDs. And that's sort of the source of object IDs. But you can also then take, for a group, we've got all the prop information. We can take the prop object IDs and we can hand that branch down to the prop department. And the prop department says, oh, the truck, there actually are 3 toy trucks. There's the new truck, the clean truck, the broken truck. There are 3 new object IDs for it, and those object IDs have parentage. They have inheritance from their parent. And the way how it happens in the web industry is when you create new objects, you typically feed that information back up to the parent so that the parent now knows about these new objects. And once this starts happening, then suddenly all the various forms of metadata that are around become interoperable and useful. And then finally, and this is on a different subject, I'd like to thank my college, City College, San Francisco. I'd also like to talk to you about students and entry-level jobs. My students, my friends are seeing that most of the entry-level jobs are going away. And this is a significant problem for the industry because if we don't hire our students, our newbies, the entry-level positions, what the industry is going to discover in about 5 years, when the graybeards start retiring and everyone's moving up and they finally need to move somebody from the rung 2 of the career ladder up to rung 3, they're going to look there and there are going to be no rung 1, rung 2 employees that have been moving up the chain. And suddenly in 5 years, you're going to say, we can't find any junior level employees. This is an argument that you can make with your manager. You and your manager can make it with HR. You, management, and HR can make it with the board. We need to hire our students. I know we can save money by doing AI and stuff, but we have to give young people experience in the industry so that they can mature into more senior roles. And that's it. Thank you.